Right, so welcome to another segment of my physics O-level, lessons. We are still continuing under lenses, but this time we are looking at the thin lens equation, or the thin lens formula, as it may be called. And this is what I told you is the formula for the thin lens, equation or formula. 1 over the focal length is equal to 1 over, remember our u is representing the object distance from the lens, plus 1 over the image distance, that is from the lens again. Now sometimes it is easier, they may tell you to find the focal length, so we can work out this formula so that we've reduced it to its simplest form that you can work with. So if you notice there, we can carry out our simple mathematics using algebra by simply saying 1 over the focal length will be equal to, we can find the common denominator in that case for that, and when we find the common denominator for u and v, what we are going to have there is simply uv. So we can have uv over, when this goes, the u goes into the uv, the u and the u cancel, I'll remain with a v. V times 1 will give me a v plus. When v goes into the common denominator, the v and the v will cancel, I'll remain with a u. U times 1 will give me a u there. Then from here, we can now cross multiply. So when I cross multiply, it will be the focal length times v plus u, which is equal to 1 times that will still give me uv. To find f, I can simply divide v plus u. What I do this side, I'll do it even the other side. Remember this and that will cancel. I'll remain with f is equal to uv divided by v plus u. So this is the formula that we can use to calculate what we are calling as being the focal length. So it's very simple. Remember, our u again is representing what we are calling as being the object, distance from the lens, and our v is representing what we are calling as being the image distance. Again, that starts from the lens, and our f is representing what we are calling as being the focal length. So when you want to calculate the focal length, it is easier for you to use that. Again, there's another thing that I actually talked about. Let me just turn it the other side. We did establish that they can also ask you to calculate linear magnification, which is equal to v over u. In other words, the image distance divided by what we are calling as being the object distance. Now, I just want to highlight a few things under linear magnification. Remember, linear magnification represented by m there, others use small letter m, it's possible you can use that, does not have units. So this guy, no units. It's a ratio, so it doesn't need to have units. Now, a few quick tips that you need to remember when you are in the exam. 1, when the magnification m is actually less than 1, it simply tells you that the image that has been formed is actually, the image will be diminished. Remember, diminished in this case means that it is smaller than the object. So when m, your magnification is less than 1, just know that the image is diminished. What about if the magnification is equal to 1? Well, when the magnification is equal to 1, it simply means that the image, the image is the same size as the object. So that's what it simply means when you find your magnification is equal to 1. What about when your magnification is greater than 1? What's the conclusion? Well, it simply means that the image that has been formed, the image is actually magnified. In other words, it is actually larger or bigger than the object. So these are important concepts that can quickly help you, because in the exam they can ask you, what are the properties of the image formed? So is it diminished? Is it the same as the object? Or is it magnified? So these tips can quickly, assist you to do that. Now, when it comes to the thin lens equation we talked about, there are some few sign conventions that you need to pay attention. So when it comes to the thin lens equation, what do I mean? I mean that equation we talked about, 1 over f is equal to 1 over u plus 1 over v. They are what we simply call as being sign conversion. So there are some sign conversions, used. There are sign convention used when it comes to the length equation. But what are these that we are going to talk about? Let's take, for example, if you are talking about maybe, let me say, you are talking about two types of lenses. I would simply talk about here. Maybe I can give you a short summary of that. I can give you a short summary, just a minute, so that you are able to see there. I can give you some sign conventions that you can quickly use. So you can simply talk about maybe this one positive, and you can simply talk about the other side being negative. So it may be in terms of what we are calling as being the focal length. Remember, f is the focal length. And we can also talk about v. Remember, v is representing what we are calling as being the image distance. So that is the image distance. Now, when you are using this formula for a convex lens, when you're using a convex lens, when applying this length equation, you're going to find that the focal length is supposed to be, it will give you positive. The image distance is always supposed to give you, again, positive. Now, when it gives you positive for a convex lens, it simply means that the image that has been formed is actually a real image. When you find that your image distance is positive, it simply means that it is a real image that you're talking about. But of course, if you find that again it is positive, it simply indicates that the image is actually on the opposite side, on the opposite side of the object. I'm sure you remember that, on the opposite side of the object. That is what you're going to find. But if you're using, again, still a convex lens, and you find that it gives you, your v gives you a negative, it simply means that the image that you have is actually virtual. And of course, if it is virtual, it simply means that the image is on the same side as the object. So please take heart. I'm going to apply this concept in my next video. Please like, follow, and subscribe on my channel so that I can produce more videos of that. See you in my next video, where we are going to look at practical examples on how to use the length equation, how to calculate the magnification, and so on and so forth. See you in my next video.